The pneumatic system supplies pressurized air for engine start, air conditioning, pressurization, and wing and engine anti-ice. Controls and indicators for the pneumatic system are located on the overhead panel. Air to the pneumatic system can be supplied by the engines, APU, or a ground air source. APU pneumatics is available in flight up to a maximum of 20,000 feet. The pneumatic system is comprised of two separate ducts, left and right. Each duct is supplied with low and high pressure bleed air from the respective engine. A high pressure valve automatically modulates the high pressure air. Engine bleed valves regulate the bleed air supplying the pneumatic ducts. A single duct pressure indicator has a left and right needle that indicates pressure in the respective duct. An isolation valve allows either engine to supply both pneumatic ducts. Now let's discuss normal operation. The engine bleed air off light illuminates, accompanied by the associated ICAS message when the engine bleed valves are closed. The engine bleed air off light indicates the bleed air valve is closed regardless of switch position. Selecting the engine bleed air switch on, with engine bleed air available, opens the engine bleed air valve. The APU bleed air switch connects the APU to the pneumatic system. The switch does not have an off light. Setting the APU bleed air switch on allows bleed air to flow into the left pneumatic duct. An isolation valve allows APU bleed air to pressurize the right pneumatic duct. There are two ground air connections, one in the left pneumatic duct and one in the right. Two air sources are required to supply the volume of air needed for two-pack operation or engine start. Now try a few questions. Now let's discuss abnormal operation. Overheat loops provide bleed air leak detection along the left and right pneumatic ducts. The duct leak light illuminates, accompanied by the associated ICAS caution alert, when a duct leak is detected. To correct the condition, set the affected engine bleed switch off, which will remove the air source. This isolates the leak and prevents structural damage. If the isolation valve is open, press the isolation switch to close the valve, which will isolate the leak. If the leak is in the left pneumatic duct, the APU bleed air switch should also be selected off to prevent APU bleed air from supplying the affected duct. When the temperature along the duct cools, the duct leak light will extinguish and the ICAS message will be removed. The bleed light and associated caution alert indicates a malfunction exists within the associated bleed air system. The high stage light and associated caution alert also indicates a bleed air malfunction. In addition, illumination of the engine bleed off light with the bleed switch on and the engine running indicates the associated bleed valve has closed due to a malfunction. In all three cases, cycling the affected engine bleed air switch will reset the bleed air system and extinguish the advisory lights. Now try a few questions. Now let's discuss 767 pneumatic differences. The 767 pneumatic system is comprised of three separate ducts: left, center, and right. A check valve on each side of the center duct prevents one engine from overpowering the other. Normally, both the left engine and right engines supply air to the center duct. 4 systems use air from the center duct: forward cargo heat, aft cargo heat, bulk cargo heat, and the air-driven hydraulic pump. The center isolation switch controls the flow of air into the center pneumatic duct. The switch is guarded and normally left in the on position. There is an additional duct leak light for the center pneumatic duct. If the left or right duct leak light fails to extinguish after the bleed air source is turned off, a leak may exist between the isolation valves. A leak in this area should not create a serious hazard because the duct is in a protected area. The 767ER has 2 additional valves: the left and right pressure regulating valves, or PRVs. The PRVs were added to provide increased overpressure and overtemperature protection for the pneumatic system. The PRV operates in conjunction with its respective engine bleed valve. Overheat lights have replaced the 757 high stage lights. An overheat light will illuminate, accompanied by the associated ICAS message, if a bleed air overheat occurs.